Hello everyone, welcome to the third video in this series of Java, Introduction to Java. In today's video, we're going to be focusing on primarily how to declare variables, how to initialize variables, and also discuss the 8 primitive data types that you will find in Java. We'll also dig into something called binary, and what does that mean in terms of memory allocation, and how do we allocate certain characters to certain numeric values, and how that's stored in computer memory. And then we'll get into escape sequences. And so this video will focus on primarily everything that you see in this third bullet point, and then we'll do a quick review over some of the things that we went over in the second video in this series. All right, so let's talk about how to declare and initialize variables and what is this thing called primitive data types. So we're going to skip ahead here. Before we actually talk about declaring and initializing variables, in the previous video, we created a simple program, and I showed you 2 different ways of doing that. One, using the Java command line and how to compile and just create a simple Java file and to create the class bytecode file. And then the other way was basically using some of the extension tools that we have available within Visual Studio Code, and you can just click on create Java project, and it will pre-scaffold your application to the folder structure that you see on the left. I'm going to make this just a little bit bigger. There we go. So in this application here, we have an app.java file, and we have a class called app, and then we have a main method, and it has one statement. Now, when you're declaring variables within the main method, because when you execute your program, it's going to look for a method called main, and it's going to run everything from the top of that main method to the bottom. So everything in between the opening and closing bracket. So when we declare variables, typically you'll put them towards the top of your method. And so I like to put a comment here that says declaration. I just want to do 2 examples of declaring variables, and then we'll talk more about the different primitive data types and what values would you want to store into these data types. So the first one here you'll commonly see is integer, right? Now to say a number, let's just say 23, right? So we have the data type, which is int. The variable is called a number, and then what we're going to do is we're going to initialize a number to hold the value 23. And notice that there's no quotation marks around 23, but there's 3 parts here, right? We have the data type, we have the variable name, which is a number, and then we have the value that's going to be assigned to a number. So this is basically initializing, declaring and initializing all in one step. Sometimes you'll see folks will do something like this. They'll declare the variable, and then they'll initialize it in another step. So they'll say, or another statement, and they'll say a number equals 23. Now, you will also see another data type. Let me see one more example of a different data type. And this would be called the double data type. And we just say, let's say salary. So in this case here, I just declared the variable, but I didn't initialize it. But I'm just going to do this all in one step. So I'll declare it and initialize the variable. And so let's just say the salary would be $23,000 a month, right? And you'll see that we have the decimal point for the double data type. And so this is just 2 quick examples of how to declare a variable and then initialize it or assign a value to the variable. So here in this first step, we declared the variable, and then we assign a value to this variable or initialize a number variable to 23. And then on line 9 here, we just declared and initialized in one statement. Okay, so let's talk about a little bit more about the ranges and the types of different data types we have within Java. So here, declaring and initializing variables, right? So there's some terms: constant, literal constant. There's different data types. And in Java, there's 8 primitive data types. Now we could create our own data types, which we'll get into a little bit later. And and then there's Unicode. And we're going to talk about this idea of binary and then how data is actually saved or stored into our machine. And you'll see that it saves the data in 0 and 1s, right? Every character on our keyboard has a numeric value. And let's say, for instance, the character A, the numeric value in ASCII code is 65. But then 65 translates to 0 and 1s because the computer can only understand 0 and 1s. And so we're going to talk about how to convert the character A into machine code language that the machine can actually interpret. So we'll talk more about that in just a second. So here's a visual of the 8 primitive data types. So we have Boolean, which is true or false. We have the char, which holds a character, such as, and each one here gives you an example of of how you would declare and initialize that variable. To the right here, where my mouse is hovering. And then here you have the range. So what data is permissible for each data type? And so, for instance, if we take the integer, you can only store a number that's between this value here, where my mouse is hovering, and up to this value, right? So if you need a bigger value, you'll probably want to do a long data type, and this holds a bigger range than the integer. And then in the description here, it'll tell you kind of what type of data type, or it gives you a description of the data type. So with Boolean, it's true or false, 0 or 1, right? And then here for integer, it'll say signed integer. But the question is, what is signed integer? In short, a signed integer allows you to have both negative and positive values. If it's unsigned, you can only have positive values. And so Java supports signed integer values, and some languages support both signed and unsigned, where you can actually declare an unsigned, which is only positive, and a signed, which gives you the negative values as well. And then this column here, size, you'll see the terms bit and bytes. Is basically allocating how much space and memory when we begin to declare these variables and assign certain values to them, how much space and memory will we need to reserve for the data that will be assigned to the various variables. And so we're going to have an activity that talks about how this gets translated into machine code and how this gets stored into memory. All right, so here's a quick video that's going to introduce you to bits, bytes, and then binary, and then how does that get translated to the ASCII chart. So what does the letter A represent, or B represent, and in its numeric value, and then how does that get translated into binary? So I would say pause this video, watch this video, and then we're gonna have a short activity on the next presentation slide in terms of how we can actually convert decimal numbers into binary, and then vice versa, binary numbers into decimal numbers. All right, so hopefully that video was helpful in helping us understand how binary works, and so how we could convert a decimal number into binary, and vice versa, a binary number into decimal value. But also, how does the ASCII chart play into this, right? So each character, each symbol has a specific numeric value behind it. And then ASCII is just a part of the Unicode system, right? It's a small portion of it, but Unicode is a little bit more exhaustive in the sense that it encompasses a number of different languages. So this learning activity is just going to give us a little bit more practice with what we just seen in that video. How do we convert decimal to binary? I'm going to show you a few methods in terms of how to do that, and then how to convert binary values into decimal numbers. All right, so let's take a look at this activity here. So the first question here is, are there any recognizable patterns you observe from the chart to the right here? So with the binary number, as we see that it goes up in place, right? We see that the decimal number doubles in size. So 2, 4, 8, 16, 32. If we continue this on, it will go down to 64, 128, 256, and continue on. And so what we want to do is just get some more practice here with converting from decimal to binary, and then from binary to decimal. So the first number here is 92. And so what I've done here is I've created what we've seen in that chart, the pattern that we saw. So 128, 64, 32, 16, and so forth. And we want to basically convert this number 92 into binary. Well, the easy way of doing this here is to say which numbers here would actually equate to 92. The numbers that equate to 92 are 64, 16, 8, and 4. So if you add those together, that gets us 92. But what if you didn't know, like, hey, which combination of numbers would get 92? There's the subtraction method that we can use that will allow us to also get the binary number. So the way you would do that with the subtraction method is that we will say, can we subtract one of these numbers from our decimal number? So in this case here, we cannot subtract 128 from 92, so we're going to put a 0 under here, right? But then we can subtract 64 from 92, so we'll say 64 to jump over to my tablet here so I can actually write a little bit better on the screen here. So we'll say 64 from 92, and that's going to give us 28, right? And then, so because we can subtract 64 from 92, so we'll put a 1 there. The question is now, can we subtract 32 from 28? No, so we put a 0 there. Can we subtract 16 from 28? Yes. So we can say 16 minus subtract from 28. That'll get us 12. Because we can do that, we'll put a 1 there, right? And can we take 8 from 12? Yes. Get us 4. Because we can do that, we'll put a 1 there. And then can we take 4 away from 4? Yes. So minus 4. That'll give us 0. Because we can take it away from 4, we put a 1 there. But because 0, we can't take 2 from 0, so we put a 0. We can't take 1 from 0, so we put a 0 there. So that's another way of converting decimal number to binary. So the second question here is, how do we take a binary number and convert it to decimal? So if you look back at our slides here, here's our binary number, and we want to take that and convert it to decimal. So that number, let's go back to our whiteboard, and I'm going to erase a few things here quickly. And the number that we want to convert, the binary number that we want to convert, is this number here. I believe that was 100 110. And it's pretty straightforward when you're taking the binary number. You would use kind of the same values here. And what we're going to do is we're going to start on the right. So the trick here is to start on the right, and then we want to just place the numbers underneath our various numbers here. And what you want to do is you want to only take the numbers that have 1 and then add them up, and then that will give you your decimal number. So if we take 128, 16, 4, and 2, it should give us 150. That would be our decimal number that will stem from this binary number. So the decimal value of for this binary number is going to be 150. So what I would like for you to do is, when you get a chance, practice this on your own. So we only did 92, and we did this first decimal value. I'm sorry, what is the decimal value of this? Yeah, so we only did this first one here, 92, and the binary number here. But take a stab at taking this decimal value, 203, and convert it to binary, and then take a stab at converting this binary value and convert it to decimal. And don't forget, what's the big purpose of understanding binary, right? And so we started this lecture off with, or this video off with, data types, the primitive data types. And so whenever you declare a variable, you're declaring a variable because you're going to ultimately store some type of value into that variable. And so if you have an int, a short, or a long, these are some integer values, you want to make sure you choose the most appropriate data type based on the size of the value that you're trying to store into that variable. So with the developers of this language, right, they decided to own 8 primitive data types. And these primitive data types represent different values that can be stored into different variables. Some of them have different ranges. And like the question is, why do you have 8 primitive data types? How come we just can't have one and have one data type that would actually hold everything? And it's really about how we reserve and partition memory. We want to be conservative with our memory so that we're not reserving too much memory for a small, let's say, for instance, a small character, right? And so we have these 8 primitive data types so that we can be cautious of what type of data is going to be assigned to a particular variable, because that's going to allocate a certain amount of memory for our variables that we declare and initialize ultimately. So we start this video off here with this program here. We declared 2 variables, a number and salary. So this first here we declared, and then we initialized in a different line, and then on line number 9 we did both. We declared and initialized. Let me just do a quick example of 2 more variables. One is the char. And with character, you would use single quotations, and let's say A, right? Everybody wants to earn an A. And then the second one here would be a non-primitive data type, let's say string. And we give it the variable name. The variable will be, let's say, a name. And we'll just say prof 14. Right? So with this variable, we give it the variable a name, and then we give it a string. With string, you have the opening quotation and closing quotation. So these are just some examples of how you would declare and initialize a variable, right? Play around with this, look at the chart, refer back to it when you're declaring and initializing variables. But this is a good start in terms of helping us understand how to declare, initialize variables, and then what happens in memory when you declare a certain data type. Right. Stay tuned.